Alright, today we are looking at all of the things that we need to know for the topic linear relationships. The first thing is midpoint. So this here, what I've drawn a box around, is our formula. So what's the midpoint? Can anyone tell me what the midpoint is? Yes? Yeah, great, it's the middle. So I've got these 2 points, they're my coordinates, and I'm trying to find what point is directly in the middle. So the way I do that is I find the average of x and I find the average of y. So does anyone remember what an average is? Remember when you were doing data? Yeah, cool. To find the average of something is when you add them together and then divide by how many scores there are. Well, that's what you're trying to do here. You're trying to find what the average is of both x and then y. So what we do is we've got x1 plus x2 and we divide that by 2. Then we've got y1 plus y2 and then we divide that by 2. But first, I want to go through step by step how we do it. So, when we have a set of coordinates, which one's x and which one's y? Great. So this is x and this one's y. But what do I call them since they're my first set of coordinates? Awesome. This is x1 and this is y1, purely because that's my first coordinate that I've been given. This one here, which is x and which is y? First one's x, second one's y. So what do I call those? If these are x, yeah, awesome. Great, so the very first step is to label your points. So your first set of coordinates is x1, y1, your second coordinate is x2, y2. Now make sure you put the little 1 and the little 2 down the bottom because you're not trying to square them or anything, you're just labeling them as it's the second x. Cool, now I'm going to rewrite my formula. X1 plus x2 divided by 2, and then I've got y1 plus y2 divided by 2. But in the place of x1, what am I going to put? What's my x1? 2. Great. What's my x2? Great. What's my y1? Yep, and my y2 is 20. Great. So I've taken my formula and all I've done is chuck these numbers in the place of the letters. Any questions so far? No? Cool. So what's 2 plus 12? 14. And that's going to be divided by 2, but I'm not going to do that just yet. And what's 6 plus 20? And that's also divided by 2. Cool. Now, I divide this top number by 2. So, what's half of 14? 7. And what's half of 26? 13. Fantastic. So that is our midpoint. That is exactly halfway between those 2 points. Alright, so let's take a look at how we calculate the gradient from a graph. So we're looking at an equation that's been graphed here, and we want to try and find our m, which for some strange reason stands for gradient. Any ideas as to what we might do?
The rise over the run.
Triangle.
Awesome. We are going to do rise over run, and we have to do the triangle thing. Fantastic. So what we do is we sort of run our fingers across and down until they meet. So I'm going to draw a dotted line across until it's in line with my previous, I'm going to draw a horizontal line until it's in line with this one. Then I'm going to draw a dotted line down. Does that make sense? Yeah? So I've drawn a perfectly horizontal line out until it's in line with this point, and then I've drawn a vertical line all the way down until it's in line with my first point. Forms a triangle. Now that I have a triangle, I might actually make it a bit darker because it's on camera. Now that I have a triangle, how can I calculate my rise over my run? Any ideas? Peter?
Calculate the distance between
my line goes up. So if it's at -1, it goes, that's 1, that's 2, that's 3, 4, 5, 6. So it goes up 6 places on my graph. Does that make sense? Great. How many places does it go across? That's what I want to do. I want to count from my line to my point. So it goes across 1, 2, 3. Now, which is my rise? Yeah, the one that's going up. Great, because rise is like, it's rising up. So my rise, M for gradient, so rise over my run. My rise is 6, and my run is 3. Cool.
Oh, that's why I said rise run.
How many 3s go into 6?
2.
Cool, so my gradient is 2.
Oh, that's so easy.
Now what that actually means is that for every one point that my line goes across, it goes up 2 spaces. It goes across 1, goes up 2. Goes across 1, goes up 2. But yeah, important thing to know is draw your triangle and then count your spaces. How many spaces does it go up? Okay, next up we need to be able to identify the different types of gradients. So here, this one is our most common one that we tend to work with. What kind of gradient does that have? Great, it's positive. Because it's sloping upwards. Think about it like if I was walking from here to here, I'd be walking up a hill, so I'd be using lots of energy. So it's positive, that's a plus. What about if I walk from here to here? Would I be using just the typical amount of energy?
0.
Yeah, awesome. 0. It's like standard. It's neither positive, it's neither hard nor easy, it's just normal. So it's got a 0 gradient. This one here, yeah, awesome, it's undefined because it's not possible. And then lastly, negative. Great. So when you are looking at your graphs and you have a line that's sloping downwards, when you calculate your rise over run, at the very end you need to take a look at which direction it's sloping in. If it's sloping upwards, you don't need to do anything else. But if it's sloping down, you need to make sure your answer is negative. Yeah? So that's the downside of calculating the gradient from a picture like we just did, because it won't tell you if it's positive or negative. You have to look at it and make that call yourself.
But couldn't that be positive or not be negative?
Sorry, this one?
Yeah, couldn't that be negative?
No, because negative slopes downwards. So you always read a graph from left to right. So if I was to walk from here to here, so that's on the left, that's on the right, I'm going up a hill. So it's
you never
positive.
read a graph that way?
No, never. Read it like you're reading a book. Start from on the left-hand side, read to the right. So, yeah. This one you can't do that. You can't read from left to right, which is why it's also another reason why it's undefined. So yeah, also if I'm reading from left to right like a book and I'm starting here and I'm finishing here, I'm walking down a hill, it's negative. So I can't stress this enough. Make sure that even if you calculated your gradient like we did before with rise over run, make sure that you stop and look at the shape, like the direction that the graph is going, and make it negative if you need to. Now what we want to do is we want to figure out what that plus c does on the end of an equation. So we already know that m stands for what? Gradient. Which is why when we were doing our rise over run a minute ago and we got the answer of 2, that would mean that in an equation, instead of m, it would have 2. Yeah? But what does this c do over here? What is that?
Intercept.
Awesome. And what is a y-intercept?
Where the line crosses over on the y-axis.
Amazing. It moves our line up and down, tells us where it's going to cut through along our vertical line here. Which is x and which is y out of these two lines? Awesome. X is this one, Y is this one. So if it's plus 1 on the end, what does that mean?
It's going to cross over at 1.
Great, it's going to cross over at positive 1. So it's going to have a dot right there. And then the line's going to go something like this. The important thing is it cuts through at positive 1. What about this one here? Where is that going to cut through? Great. So I just count down to -3 and have a dot there. My line is negative, so which way is it going to be sloping? It's going to be coming down this way. So what that means is for every one it goes across, it's up 2. Every one it goes across, it's up 2. And so on and so forth. So it'll be like that. Oh, if I could draw a straight line, it would look much better than that. But anyway, it's supposed to be straight. Anyway, okay, cool. Important thing to know is it's going to cut through at -3. What about this one over here? What's the y-intercept on this one?
Nothing.
It's nothing. So whereabouts on there do you reckon it's going to cut through? 0. Cool. Because it doesn't have a y-intercept, what that actually means is there's a +0 on the end. We just haven't bothered to write it because how do you +0? Why waste your time? So if you ever have one that doesn't have a plus something on the end, it's going to cut through smack bang on 0. Have I lost you? A little bit. Do you want me to explain that last one? No? Okay, so this one, what kind of gradient is this one going to have?
Straight, the undefined one.
No, because it's got a gradient of 2, but it's positive, so it's going to be going upwards. So for every one it goes across, it goes up 2. Every one it goes across, it goes up 2. 2. And it'll look, if I please go through the right dots, yes. Yeah. Straighter than the last one. Cool. Any questions about that? So whatever number's written on the end here, let me get a different colour. Whatever number's written on the end here tells us where to put a dot on our vertical line. Yeah, I'm just putting it up. Yeah, so don't worry about the rest. The important thing was this. So if I had one that had, y equals 5x plus 1, whereabouts would that cut through? Where would I put a dot on here? Yeah, cool, a +1. Go there. And that's all I wanted to show you. Oh. Yeah. Okay, next up, we're going to look at a graph and we need to figure out what its equation is. Just by looking at it, without having to do any calculating at all, I can see where it cuts through where. Great, so I can figure out what C is going to be. Because it's cutting through at -1. So straight away, so it's going to be y equals something x plus something. So here, instead of plus, it's actually going to be minus, because it's at -1. So that bit's done. Didn't have to do any calculating, I just looked at my picture and went, oh, cool, it cuts through that line at -1. So I put that on the end.
And 1 because every time it goes across 1, it goes
Awesome.
up 1.
So every time it goes across 1, it goes up 1. So my rise is 1, my run is 1. So rise over run equals 1 over 1. How many 1s go into 1? 1. So that has a 1, the gradient of 1. Does that make sense? Based on that expression, I'm going to say no, it doesn't. So let's try again. Right. So I know that it's got a -1 at the end because it cuts through at -1. But I now need to find what my gradient is, what the m is. And the way we calculate gradient is rise over run. So I can pick any 2 points. So let's pick this one. And I don't know, let's pick this one over here. I'm going to do a line down until it's in line with that point. Line across until it's in line with that point. I can calculate my rise over run. It goes across how many points? 1, 2, 3, 4. And how many is it going up? 1, 1. Now, is my line positive or negative? Positive. So what do I have to do to it? Nothing. It's already positive.
Yeah.
Great. But if my line were negative, I'd have to make that 1 a negative 1. Let's do one of those. Can I rub this off? Alright, now we want to do it with another line. Let's practice. So, the very first thing that I can see here, without having to calculate anything, I can figure out one of these things. What is that?
X plus
Without calculating anything, what is my C on the end?
3.
Where is it cutting through?
2.
1, 2, it's cutting through a positive 2. So, that's 2 on the end there. And the reason for that is because that's where it's cutting through here. So that's my C.
2.
Yeah?
2x plus 2.
Loving it. How do we do it?
Because each time it goes down by 2 each time.
Awesome. But let's draw a triangle. So I'm going to pick this dot and I'll use this line because it's pre-drawn for my viewing convenience. Let me get a different colour. Actually, let me redraw that triangle in a different colour. So what I've done now is I've picked any 2 points along my line. I just randomly picked these 2. And what I want to do now is calculate the gradient. M equals rise over run. How do I figure out what my rise is now that I've drawn a triangle?
You're going to calculate
7.
I count. So 1, oh, I drew this really badly. It's not even. 1, 2, 3, 4. That's 4. And going across is 1, 2. So my rise is 4, my run is 2. What do I do now?
2 goes to
Oh.
Awesome. So how many 2's go into 4? Great. So it has a gradient of 2. Now the very last thing that I do is what? Before I move on to the next question, is that the correct answer?
Are they positive?
Are they positive? Is this a positive line?
Yeah.
It's negative. Because if I walk from this point to this point, am I walking up or down a hill? Down. So it's negative. So this has to become negative. Okay, now what we want to do is calculate, fill in a table of values from this equation. So I don't like multiplying with negatives. It annoys me. So I like to ignore those. And I start at 0, always. So when x is 0, what's going to go in this box? So 4 times 0 is? 0. Plus 3? 3. Alright. 4 times x, so 4 times 1? 4. Plus 3 is? 7. 4 times 2? 8. Plus 3? 11. Cool. So what are they going up by? 4. Great. So what's this one going to be down here? Negative 1.
6.
And then what's this one going to be?
Negative 5.
Cool. I could do it in a calculator. You are allowed to bring a calculator. Please bring a calculator to the exam. But if for some reason your calculator dies or you're feeling enthusiastic and you want to do it in your head, always start with 0. Always. You can't go wrong with that. Now what we want to do is we want to graph this baby. So what's the first point that I can plot easily?
0.
Yeah, 0, 3, because I know at the very end of my equation it's gonna cut through a positive 3. So 1, 2, 3, it's gonna cut through here, so that's my first point done. That's that one. The next one, these are sets of coordinates. So this one here is 1, 7. That's that one. The next one is 2, 11. They're just written like tilted, if that makes sense. So where's 1, 7? How do I find 1, 7? Do I go up to 1 and across to 7? or across to 1 and up to 7?
Wait.
Awesome. Across to 1 and up to 7. So 1, 2, 3, 4, 5, 6, 7. I don't have enough spots on my graph to do the next one, but it'll be somewhere up there. So let's do this one. How do I find -1, -1? -1 down to -1. And then the next one.
Across to -2 down to -5.
Awesome. 1, 2, 3, 4, 5. It'll be down here. Then I connect my dots. Yay! Sort of straight, maybe.
Number 1.
We're rearranging. So, these equations on the board are hideous. I don't know how to graph this rubbish. If I saw a question like this, I may cry. After that, I then rearrange it. So we want it to be in the form y equals mx plus c, because then we can graph it. That makes it easy for us to graph. This here, gibberish. This here is called general form. I don't even know why it exists, but it does. So let's fix this mess.
-1.
Great. First, my goal is to have y left over this side. Everything else, I want to move. I want to get rid of everything else.
-4.
So, great. I'm going to -4x from this side, and I'm going to -4x from this side. So, over here I'm left with y plus 3 is equal to, what's 0 minus 4x? Yeah. Great. Now what do I do?
-3.
Great. I'm going to -3. So this side I'm just left with y equals -4x minus 3. How's that? Is that in the form that we like? It is. Hooray. Success. Let's do it again. This one looks a lot more ugly because it's got some bigger, weirder numbers and some negatives.
Plus 19x.
Why don't we get a formula?
It's so easy. I know. It's just like having a
Alright, so the first thing I did was I added 19x to both sides. That gets rid of that. What I'm left with is y minus 9 equals 19x. How do I get rid of that minus 9? Great. I'm going to add 9 to both sides. Add 9. So y equals 19x plus 9. Alright, next up, parallel lines. On the board, I've poorly drawn 3 parallel lines. What do you notice about them? What do they have in common? They're parallel. Awesome. I'm going to repeat that for anyone who wasn't necessarily paying attention. Here are 3 parallel lines. You've got to use your imagination because I can't draw, but nevertheless, what do they have in common? They're parallel, and what makes them parallel? Yep, but what about their equations? If you look at their equations, what do they all have in common? Awesome, they all have the same, the same what? The same gradient. Fantastic. So, parallel lines have the same gradient. The plus c on the end just moves the line up or down, but they will always stay parallel if they have the same gradient. So I could have a y equals 1x minus that number, and it would still be parallel because y has the same gradient. Awesome. Alright. If I have the numbers, the equations y equals 3x plus 4 and y equals minus 3x plus 4, are they parallel?
No.
No, why not?
Because it's negative.
Awesome, one's negative, they don't have the same gradient, therefore not parallel. They have to have the same gradient. So, if and when in your free time you come across 2 lines with the same equation, with the same gradient, they're going to be parallel. Any questions about that?
No.
Is that it? That's it.
Yeah.
So, actually, you know what? If I asked you to come up with an equation with a line that's parallel to y equals 5x plus 6, what might be an equation that you come up with?
5x plus 20.
Yeah, great, awesome,
20,000.
awesome. Yeah, anything, so long as it starts with 5x. Last dot point. We want to find out what the equation is of a line that's perpendicular to the black one. So perpendicular means what? Yeah, it cuts through at perfectly 90 degrees. So every single angle that comes off here, that's 90 degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees. Think of it like if I was drawing a plus, that's perpendicular. So it's directly in the 100% opposite direction. So like, yeah. Anyway, so I need to create an equation for this line, or I need to figure out what the equation of this line would be. The way I do that is, which one here is m? Yeah. No, this is my plus c, that's plus c, this is m. Yeah, my negative 4 is m. So here I'm trying to create one that's y equals mx plus c. This is going to be my m2, this is my m1. Yeah, because it's the first m. Anyway, so negative 1 over m, m1. And that's it. Okay? So that's my equation of how I create one that's perpendicular. I take my m and I put negative 1 on top.
Okay.
So it's going to be negative 1 over, what's my m here? What's my m1?
Negative 4.
Great. Great.
Oh, yeah, that's
What am I going to say? 2 negatives give me a positive, so this becomes 1 over 4.
Oh, the first time you did complete that.
Have I lost anyone?
Yes.
Okay. Now we want to create the equation for this black line here that cuts through this blue one. The blue one's equation is y equals 5x minus 1. So, to create a perpendicular line, you just put negative 1 on top of whatever your m is. Yeah? My m is what in this? 5. So this is my m. You know, y equals mx plus b. M stands for gradient. So this is my m.
Just do negative 1 over
Yep.
gradient.
That's it. So, instead of m, I'm going to be writing 5.
That's literally
So negative 1 over 5. That's literally it.
Yay!
Whatever your m is, you take it, put it on the bottom, and put a negative 1 on top. And there you go, perpendicular lineage. Happy days.
You got a coffee that you can have.
The only time it gets a little more complicated is if you've got a negative something. Okay. The only time it has an extra step is if for some reason your equation is a negative. In which case, it's negative 1 over whatever that number is, and you just cancel out the negatives. So if we want to test if a line is perpendicular, say they give us 2 equations, we want to find out, are they perpendicular? This is my first m. That's my m1. We should draw a line so it makes it look like a division. That's my m1. This here is my m2. Purely because that's the first equation, that's the second one. It doesn't matter which order I put them in, it doesn't matter. So my m1 is 7. If I times it by m2, does it equal negative 1? No, it does not. Therefore, not perpendicular. If you got ones that do multiply to negative 1, then yes, they're perpendicular. But if you get 2 numbers, I don't know, like 6 times 3, Does that equal -1? No, it does not. Alright, so if I had an equation that had a gradient of -1, and if I had another equation that had a gradient of 1, -1 times 1, does that give me -1? It does, so that would be perpendicular. However, the other ones, no, they don't multiply to -1, then they're not perpendicular. And that is it for today.